Today we're going to be talking about section 6.4, proving triangles similar by side, 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 and side, angle, side. And we're on page 11 in your notes packet. So if you need to pause the video and open your notes packet to page 11 so that you're ready to take notes, please do so now. Great. So we have our vocab for today. That should look very familiar as we've already talked about all three of those terms. All right, so let's go ahead and jump into our theorems for today. All right, so our first one says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So this is going to be our side, side, side similarity theorem, which tells us that if all three pairs of sides, right, if all three pairs, so all three pairs of sides are in proportion, that implies that the triangles are similar. We can abbreviate this using our side, side, side similarity. All right. So the next theorem, all right, it says if an angle in one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, the triangles are similar. So here we need this angle to be subtended by the two pairs of sides that are in proportion. So if we have XD in proportion to MP and then XY in proportion to MN, all right, then we know that those two triangles have to be similar. And the way that we're going to abbreviate this one is side, angle, side, similarity. It's important here that you're including that it's similarity because otherwise it's assumed that we're talking about congruence, which is totally different. All right, so now let's look at this first example. All right, use the information given to you, right, to decide whether or not they are similar using side, 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 all right? So the way that we want to compare these is if we're doing triangle DEF to triangle ABC, we want to first pair up the shortest sides, the longest sides, and the remaining sides. So go ahead and set up your proportions right now, pause the video, and then you can check your work. Okay, great. So when we compared, we ended up with all three of the sides being in the ratio of 3 to 4. So that tells us that the triangles have to be similar. So they are similar by side, side, side similarity. All right. Now, if we look at our second setup, all right, so triangle ABC to triangle GHJ. Again, we're going to set it up. Shortest pairs of sides, longest pairs of sides, remaining sides, so the ones in the middle. All right, and that's how we want to pair it up. Go ahead, set these up right now, pause the video, and then you can come back and check. Great. So if we look at this one, all right, we got 1, 1, and then we got 6 over 5, all right? And so because they're not all equal, right, even if two of them are, they're not all equal, then we know that the triangles are not going to be similar. Now let's go ahead and let's look at our similarity proof, all right? So this is kind of a long proof, and I want us to kind of just go through this together, and then you can kind of fill this stuff in, all right? So here we know that our sides are in proportion. That was our given information, all right? Drawing our point P such that JK is equal to PS, all right? So such that JK is equal to PS. Notice how that's already marked for you on your diagram, all right? Let's cut off equal lengths, right? Then we're constructing PQ such that it's parallel to RT. Again, that's already marked. And we've already learned how to construct parallel lines, so that's fair game, right? Then we know that these two angles right here have to be equal because if lines are parallel, corresponding angles are equal. And then we're also able to conclude that angle S is equal to itself. So using these two pieces of information, we can conclude that our two triangles are similar because if two angles are equal, that implies triangles are similar. So now that we know the triangles are similar, right, we can set up our proportion, all right? And then from here, we're using the fact that we can construct a triangle equal to a given triangle. That's effectively what we've done when we created triangle JKL, right? And we're constructing it such that it's equal to SPQ, all right? And so now we're using our side, side, side congruence statement. And then all we need to do here, moving forward, is to swap out triangle SPQ triangle SPQ with triangle JKL. And then I'm able to conclude that triangle JKL has to be similar to triangle SRT using substitution, right? So all we're doing here is we're taking out this SPQ and replacing it with JKL because those two triangles are similar. So this is why side-side-side similarity works. So now let's go ahead and continue and look at a couple more examples. All right, so example 2, use the side-side-side similarity theorem. Find the value of x that makes triangle ABC similar to triangle DEF. So go ahead and pause the video and let's go ahead and try to set that up on your own, please. All right, so when we do this, we're going to first set up our shortest side with our shortest side, right? So I'm going to have 4 is to 12, and then we're going to simplify that is equal to x minus 1 over 18. And then you can solve this however you like. I would not recommend cross multiplication. I would first recommend going, okay, 4 over 2 times 2 times 3 is 12 is equal to x minus 1. 18 is 2 times 3 times 3. So what did I do going from here to here? I prime factored my denominators. And then I'm just going to multiply both sides by what they have in common. So 2 times 2 times 3 times 3 times 2 times 2 times 3 times 3. That's the least common multiple of my denominators. And so now I can just cancel what they have in common. So 2, 2, and 3 cancel with 2, 2, and 3 here, leaving me with 3 times 4 is equal to 2, 3, and 3 cancels with 2, 3, and 3 here is equal to 2 times x minus 1. Again, if you're having trouble getting to this red line right here, feel free to stop by my Zoom session later and ask any questions that you have. So now I have 12 equals 2 times x minus 1. I'm going to divide both sides by 2. 6 equals x minus 1, so I get 7 equals x. And so then another way that we could have set this up is if we had done 4 is to 12 as 8 is to 3 times x plus 1. Okay, so from here we could have 12 times 8 is equal to 4 times 3 times x plus 1. Okay, we know that 4 times 3 is 12, so those are going to cancel. So now I have 8 equals x plus 1. I subtract 1, and I get 7 equals x. Oh, great, we know that we did our work correctly, all right? And so now we know that we're good to go on this problem. So now let's go ahead. We just have a couple more examples that we need to make it through. So let's look at example 3, using side angle side similarity. So first we've got to check and make sure that our sides are in proportion. So we see that we have this angle 53 degrees, and so those are equal. So now we have to check that the sides on either side of the angle are going to be in proportion. So first I'm going to match up 6 over 9. When I simplify that, I get 2 over 3. Then I match up 10 and 15, and I get 2 over 3 again. So my sides are in proportion, so the triangles are similar by side, angle, side, similarity. Great. And so now it says, we're building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so that it is similar to the left end using the angle measure and the length shown? So our answer is yes, because the triangles are similar. Great. Now you will complete this extra practice for examples 1 and 2 as part of your classwork for today, which you will then turn in on Google Classroom. So now let's go ahead and let's look at the next page. All right, so here's a concept summary. We now have 3 different ways to prove triangles are similar. We have our AA similarity postulate, which we're using our shorthand, 2 angles equal implies triangles similar. We have our side-side-side similarity, which tells us if we have 3 pairs of sides in proportion, triangles are similar, and then side angle side. All right, so now let's go ahead and let's look at example 4. Go ahead and pause the video and try to work out example 4 right now on your own. Great, so you should have worked that out. And so now let's look at how I set this up. All right, so first I have to check, are my sides in proportion? Yes, they are. Notice how I'm pairing up the smaller side with the smaller side and then the larger side with the larger side. And then I also know that my angles, ACB, has to be equal to angle DCE because vertical angles are equal. All right, and so I would use side angle side to show that my triangles were similar. Awesome. So then you're going to complete these extra practice examples on 3 and 4. This is part of your classwork assignment that you'll turn in on Google Classroom. Please stop by Zoom or send me an email if you have any questions.